Welcome to Lesson 6 of Module 1.3. In this lesson, we will explore some of the most exciting trends that are shaping the future of farming. The agricultural landscape is evolving at an incredible pace. As we move further into the 21st century, farming practices are becoming more connected, automated, and resilient. Emerging trends are focused on optimizing resource use, reducing waste, and improving productivity. In this lesson, we are focusing on autonomous farming systems and space agriculture. These are two frontiers that have the potential to revolutionize how we grow food, both on Earth and beyond. Let's start with autonomous farming. The idea here is to use robotic equipment that operates without human interventions, enabling 24/7 farm operations. One of the key benefits of autonomous systems is that they can operate continuously, unaffected by fatigue, which significantly expands productive work hours and helps address labor shortages in the agricultural sector. For example, robotic systems for seeding, crop care, and harvesting can help farmers manage more land efficiently, even during off hours when human workers would typically need rest. Another exciting feature of autonomous farming is the level of precision it brings. Consider the example of robotic weeders. This system uses computer vision and advanced algorithms to distinguish between crops and weeds. Rather than spraying herbicides across the entire field, robotic weeders can spot spray only the weeds, dramatically reducing the use of chemicals and minimizing environmental impact. This level of precision farming goes beyond what humans can achieve manually, making it one of the most promising applications of robotics in agriculture. A common concern about automation is that it might replace human workers. However, experts believe that automation will augment rather than replace farmers. The future of farming will likely involve hybrid systems where farmers manage fleets of robots, analyze data, and maintain high-tech systems. In fact, pilot projects like the UK's hands-free hectare show that autonomous tractors and combines can manage tasks like seeding and harvesting with impressive efficiency, achieving yields similar to traditional farms while reducing labor costs. Now let's talk about space agriculture, a truly exciting frontier. Space agriculture is focused on growing food in space environments to support long-term missions like those planned for the Moon or Mars. On the International Space Station, NASA has already successfully grown leafy greens and chili peppers in microgravity conditions, allowing astronauts to have fresh produce while in space. This research is not just about feeding astronauts. It provides key insight on how we can grow crops in extreme conditions here on Earth, like deserts or urban rooftops. One of the most exciting projects in space agriculture is Eden ISS, a greenhouse in Antarctica that mimics the conditions required for growing crops on Mars. This project has been producing up to 5 kilograms of produce per week, testing technologies for hydroponics and aeroponics. Similarly, the European Space Agency is leading the development of Eden Luna, a project focusing on creating plant growth modules on the Moon. The lessons learned from these space-based initiatives will undoubtedly help improve agricultural techniques on Earth, especially in areas with extreme climates. While space agriculture might seem distant, the technologies developed in this field have immediate applications here on Earth. For example, the LED lighting systems developed for space farms are extremely efficient, and they are now used in vertical farms and indoor farming systems across Europe. Similarly, advanced hydroponic and aeroponic techniques tested in space are helping us grow crops with minimal water use, an innovation that is critical as we face increasing water scarcity due to climate change. Space agriculture is not just about feeding astronauts, it's about developing sustainable farming practices for the future. As we look into the future, we see several emerging directions that could shape agriculture in the coming decades. Digital DNA-driven agriculture. Genomic data and digital tools are driving ultra-personalized crop management. Farmers can breed crops that are better suited to specific environmental conditions. Biodiversity markets. In the future, farmers may earn credits for improving biodiversity on their land, similar to carbon credits. Global nutrient recycling. Waste from urban areas might be turned into nutrients that can be used on farms, creating circular flow of nutrients. Bioeconomy. The use of agricultural biomass for renewable products like bioplastics, biofuels, and biomaterials is on the rise. Digital farm twins. Digital simulations of farms, called digital twins, could allow farmers to test various scenarios before implementing them in the real world, optimizing productivity and minimizing risk. In summary, the future of agriculture is filled with technological innovation, new models for food production, and sustainable practices that will shape how we feed the world in the coming decades. However, as we move forward, it's crucial that education and knowledge sharing continue to play a central role in helping farmers adapt to these changes. Agriculture will always need human expertise and community-driven solutions to complement technological advancements. Thank you for joining us in exploring the future directions of agriculture.